Hello and welcome to the next lecture of object-oriented programming. I'm sorry for delay. Unfortunately, I have some technical problems in the beginning, so now everything is fine, so we can continue. So first of all, I want to talk a little bit about some extra tasks. So far, I have received very few solutions that almost not complete. Again, I want to remind you what task was. So the task was to create C file .c code that after compilation in Visual Studio with default settings will finally be compiled as a program, as an application that will print on the console Fibonacci sequence, like Fibonacci number one is one, two is two, three is three, four is five, and so on. So the constraint that you have is that the code that actual like something like fib.c, let's say, this code have to have no letters at all. Unfortunately, I don't know this way how to do it without any letters because we need at least main, these four letters, to be presented in this file to be able to be compiled with default settings. Because it's an entry point, it's the name of a symbol that will be linked to the basic library, and Visual Studio will be able to connect it, to link it. So this main can be used. So these four letters exactly, and you know in what place they have to be used. But with outside of these four letters, you can't use anything else. No more letters at all. It is possible to do, and I have received a few solutions that actually removed all letters except one more option. The problem is that somehow you need to actual calculation of Fibonacci numbers, declaration of variables, for loops, if constructions, all of this stuff can be replaced without letters. Um, I will give you some hints about it later, but so far it is not that hard. But the hardest part starts when you need to print something on the console. To do that, you need to, by default, you in regular stuff, you do something like include stdio.h, and then something like uh, int main and return uh, return 0, and then you have to do something printf. So Fibonacci number d for int e. I'll give you some hints so far that I have seen the solution. So for those stuff, let me give me a second. I will show you the problem that you have. Uh, let's say 100 doesn't matter so far, and come on, why it stopped? Is d and something like e and leave on from e, something like this. So this is some pseudocode for basic implementation. So this stuff, let's look at some hints that I have seen the solution. So I'll show you some hints about how to solve and remove some letters from here. Um, And when you see these kind of solutions, you will not get pluses for those, but still you will possible to get pluses for the rest stuff. So you can remove int from here. It's fine. You can remove return. It doesn't matter. Come on. I have some slow working PC for some reason. Maybe it starts to update, maybe. So you can remove this int and put it in global scope and uh, do something like this. Come on, there it is. Come on, why it's working so slow? Okay, I can remove this and it will be fine for C to declare it like this. So I over here is not good too, so I have to replace it. Why it's working so slow, I don't know. I'm sorry. Just a little pause. I will try to remove stuff to make things work faster. One moment. And I'm back. So, okay, I hope it will work faster now. No, it still stops. Okay, so this I is not good too, so it can be replaced on something like this. And it will be integer by default. I can replace this, 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 this I can call something like 2, and this I can declare Fibonacci like 2. Come on, why it works so slow? I can't understand. Oh, it won't update. No, I don't want to update it. Okay. So I can declare a function like this, and it can be like this, and it can be 3 equals 3 plus 1. It's not Fibonacci array, it doesn't matter. I just want to show an example. So this looks also correct for C. And I can replace those stuff with octal code like 088 or 056. I don't know symbols actually what is F in octal, but you can find an ASCII table. Uh, 055 and so on. All stuff can be replaced like this. Uh, 4 constructions can be replaced by recursion. So also like this stuff. So it's also not a problem. If constructions with a question mark and colon, also not hard. But the hardest part starts here, how to replace printf. So I can remove include. It's not that hard. I can define printf somewhere. But the problem is that printf is a symbol name from the default library that knows how to print stuff on the console. And without this name, library will not link this to the correct function. And due to ASLR, we don't know the actual address of printf every time it starts. Every time in a runtime mode, when the application starts, this address will be different. So it's also impossible to like run one time, look at this address, write it here in a decimal code, and it works. No, it won't. It won't work. So the problem now is how to get option. So it can be replaced. Printf can be replaced on something more easier, like putchar. It also can be replaced on something like write file and write to it's kernel 32. So putchar is from msvcrt something .dll. Function write file is from kernel 32 DLL, so it's maybe even easier to find. So kernel 32 is a default library that links every time, so it definitely exists in your address space when it starts. MassVCRT is a not default library, it's for Visual Studio, it may not be presented. And so the goal is, so you can't use printf like here, it's letters. So for is easy to remove, so printf is hard to remove. You can't use a direct address, write it somewhere and use it as an absolute address. So the core solution will be to find this address of any function like putchar, write file, printf, doesn't matter. For my own opinion, it's easier to do everything in terms of write file and like this stuff. Uh, and because MSVCRT is not possibly present, it may not be present somewhere, not somewhere, it may not be present on the system, but kernel 32 will definitely be present. And finally, putchar will finally do a write file into the correct handle of default output. So it looks, you can look at how to, you can Google how to use a write file to write on a console. So it's not very hard. It will be something like putchar, but with the correct options. So, but still you don't know the address of write file, the same stuff, the same problem. And the solution will be to find this address in dynamic. So you start an application finds this address from its own address space. It's very good skill to understand how to work because a lot of different shellcode use this technique, and there are some different options how to do it. And it's better for you to try to do it yourself to understand how it works. Because again, the hint is that it doesn't matter what function you use, printf, putchar, write file, you'll have to find the address of this file. The address of this function in dynamic, searching it in your own address space. So think about how to do it. Again, it's possible. Another hint is that write file and putchar have a different have a different calling convention, and you'll have to create some trick how to deal with stack after this function works. It's still possible to do. It's not very hard. So you have to deal with two problems: call write file or printf. It has the same calling convention as main. Write file, no, it have another calling convention. It's easy because it will be defined and the compiler will generate the correct code, but without a declaration because it will just find an address. You'll have to call it, but you have to call it correctly due to the differentiation of calling convention. You have to deal with problem how to find address and how to deal with the calling convention. Both of these problems are solvable. It looks a little bit horrible, but you don't need to use naming like this every time. You can use your regular naming. You just know that the final step will be to replace all your good namings on this stuff. Also, I think that this task show you the power of metaphor that we have discussed previously. Where it is, where it is, where it is. Metaphor approaches metaphors. Yeah, metaphor over here. And metaphor without metaphor, your code will look like this. For a computer, it doesn't really care whether it is underscore two or Fibonacci. It don't care. It's just an address. And for this for you, it will be much easier to use stuff like Fibonacci rather than underscore two. So Metaphor is a tool that allows you to replace stuff like this on something like write file, kernel 32, something meaning with some meaning. So it's good example on how it works. Of course, in a week. So I'll give you one more week to for you to get solution. So the those of you who send me a solution with the stuff replacement that I have shown you right now will get your pluses anyway. But I'm still waiting for any one of you who send me the solution how to get address and deal with the calling convention. If you send it, you'll get more pluses. So one more week you have, and still waiting. And one more option. So this I have shown you. Okay. Yeah, I think it's fine. Now try to do it. It's really a good technique. And you'll get your next task next week. So for extra task, you'll see next week. So let's continue to talk about object-oriented programming. So we have started with some example, and we are trying to do them in UML, C++, and C. Unfortunately, I have destroyed the UML diagram, so we will create it again. We are working on C++ right now, and I will show you how it looks like in C. So, and in C, I want to show you two options. I forgot the, oh yeah, I see. So two options in uh, procedural programming way and object-oriented. So we have created a small example with basic rendering stuff. We have created this code previous time, and it was created by just putting stuff from different places, just allow it to compile, to be linked, to compile, and to draw something on the screen. Um, just to get some example. This is how a real world application are created. So step by step, the first step always is to get some, to achieve some goal, to achieve some result. In our case was to have the full code that is compilable, linkable, and it runs and draw something on the screen, because previously we don't know how to draw something on the screen. Now we can, and how to draw a circle and a square, we can deal with that. Now today I want to spend the most part of the time on working on the code step by step, by making it better and looks much more like object-oriented stuff. Then we will translate this example on C code, and we have no recent. Oh yeah, yeah, this one. Next, we'll look at the C implementation and maybe some more and more examples. Then I think that we'll make it go to the modular programming and do some wrappers and so on. So let's start creating our core example. So my goal is, let me show you. Uh, so let's add some. So what I want to do, so I think that the core thing in programming is practice. That's why I'm giving you some extra tasks to allow you to make some, to get some practice examples. And what I want to do is to create the core C++ code, and then I want to, it will be an object-oriented, good, as good as we can. Then we will create some C code from it that will be in two ways, object-oriented and procedural. Next, sorry, oh my, no, I don't need this. I I don't need this. And procedural. And next, I think we'll look at other codes like UML. Maybe we'll do it in parallel. There I am. Come on. Oh, looks like a bug. So, and next we'll do some more stuff like Chrome wrapper and use some other code like C sharp and all this stuff. So, for some reason, everything looks very slow. I don't think that I have a slow PC, but maybe I have. So, okay, my goal today is to make this code looks object-oriented way as much as we can. In this code that we have like, let's open source CPP. We don't need this project so far. We don't need this project. We are looking only on OLP example 2. I think that in next time we will rename it and work with naming stuff. But so far, today, come on, load all these libraries. Come on, it's not that hard. I'm sorry, it's very slow for some reason. So set a startup. So looking at this code, I want to close everything except this. Close all but this. Where it is? Close all but this. Yes. Opening the file. Wow. It's hard to open file with a couple kilobytes. Come on. Yeah, I think it looks for some updates. So, okay. I want to look at this code and make it a good way of object-oriented stuff with all this encapsulation, uh, inheritance like this, polymorphism, and then I'll create a UML on this a little bit more detailed way, and the way it have to be looked. Right now, we have seen that this code looks very bad because it has very straightforward structure with all this stuff like useless comments. So far it was useless, it is useless right now. We have look we have some mixed like definitions, tab defs, definition of structures, definitions of defines right again, then some declarations of functions, definition of structures again. We have some regular C style. We have this kind of calling. We have this kind of naming with fx prefix and camel case. We have some fx result stuff. On the other hand, we have DT and some very strange code over here. Yes. Then we have bad examples of code like this. I will show you why it is not good. So we have this style of comments, another style of comments. We have this strange stuff. So we have some tabs and no, sometimes spaces, sometimes stubs. We have the placements of uh, brackets, braces, curly braces over here and over here, and it is different in different places. Again, defined once again for some reason, and structures, classes again. After that, some more implementations. Some Arcanoid for some reason. It's not Arcanoid. We are creating something else. We can create actually an Arcanoid, but maybe you'll transform everything in Arcanoid. It's not that bad. But I think it's better to start with a square, triangle, and circle, and then we'll move to Arcanoid stuff, maybe. Uh, so let it be some other game with some uh, circles and square triangles. I don't know. Maybe it's better to create an Arcanoid. I'm still thinking about that. So again, we have a couple problems over here. Let's define them. I want to another blank. So problem, yes, correct. What problems we have? We have a problem that bed or like yes, bed file structure. So mixed, not ordered definitions, declarations, everything in one place. We have a too big file with different parts of app because we have in the one place a rendering engine, some definitions for shapes, some algorithmic part. So it can be splitted on a couple files and it will look much better and it will be easier to navigate because it's like 1700 lines. It's not that much, but it mixed. It's not good because one file now has a different goals. It present everything in one place. The better to split for files, one file, one goal. So one file for definition, one file for some algorithmic part, another file for rendering engine, for DirectX stuff, another option for gameplay, and so on. So return back here to big file, yeah. Okay, what else not good? Not good is different uh, naming convention. Mixing of procedural and OP style, not in not good way because some things can be replaced on the object-oriented style. Let's say the algorithmic part like Bresenham algorithm is better to keep a procedural way as we have talked before, but stuff for rendering, so things like maybe cases and all this stuff may be replaced on the object-oriented part, object-oriented stuff. So it have to be reviewed at least. Next, what's bad is bad code styling means spaces, tabs, and all this small stuff, but it makes this code look uglier. So let's start from splitting everything in files. Then we will work in each file to make things look better. Finally, we want to create. Let's make a decision first. We are creating an Arkanoid game, maybe. Let's look what we have so far. Let's compile it. Yeah, I think it's better to create an Arkanoid game as an example, and we'll make this Arkanoid game in different ways. Okay, let it be an Arkanoid. I think it's good enough. Shapes and color. Yeah, we have at least something workable. Yeah. Okay. We have behavior. So let's see, we have at least two objects over here. It's a screen, this gray stuff, and a bar over here. So I think we can move from shapes like triangle, square, circle to Arkanoid. It still will have a circle and a square, uh, maybe no triangles, and we can work with that. Okay, let's do an Arkanoid game and let's look at this and make it looks better. So let's look how many options we have. So okay, we have a DirectX include, math include, uh, some stuff for a fixed color that represents a color, We have stuff for drawing, like triangle, ellipse, line, some fixed image object. We see we have a fixed image with a create, destroy, set pixel, draw, and all this stuff. So it can be transformed to an object like a fixed image. Next, we have, so it looks like a drawing library. Next is we have a direct text stuff, which looks like a rendering option. And we have a render object, the render object with stuff like update, mouse move, like things like this. And we also, as it looks like another object. What else? I don't know what is this. So it's some implementation. It's not even presented. Yeah, it's not defined. We can remove it. Okay. So let's start by step creating the code. Before this, I think it's better to add stuff to Git repository. So you can install Git extensions to keep tracking. I think it's better to look to all this code in history way. So not now. So let's create a new repository. It will be on where I have wrappers object-oriented example over here. So it's our example. Yes, create. Yes. Edit gitignore. Gitignore is a file that has a list of files that will not be included into the Git repository stuff that is generated. So debug slash star dot dot Visual Studio slash star. Save it. Yes. Let's look at what we are. So this is a list of files that we are trying to commit to our repository. So repository is basically a zipped representation of patches. So with a look of, so all stuff is tracked or kept as diff files in zip archive. So it's like we are adding all files that we need. It's solution. It's our project. I think that we will, so it's the start point. So it will be, why do we have a C sharp? I think we don't need a C sharp. Let's look at, do we have it? Yes, we have Windows form. It's a C sharp. Let's remove it. Okay, we don't need it so far. We can remove it over here. We can select and reset. It will remove all files. Remove, update. Okay, like save. We have to see that we have a solution file again. Yes, it's a first commit. It's just a comment for our base stuff. So this is how we fix our first view of our project. So we will now work on OP example 2. We will step by step make this stuff better. We'll remove stuff like OP example 1. We don't need it anymore. We will transform this better and better to our Arkanoid game. Then we will look at this and do it in C style too, just transforming it. Okay, commit it. Commit. Yeah, now we got a first commit. Awesome. So it means that it doesn't matter what changes we will make, we'll always be able to return to this state. We can look at this over here and see each file. Now we have this C code. What it gives us, let's look how it works in dynamic. What we can do is we can, how it works. Yes, we can remove some useless stuff. We can remove this comment, and we can remove this stuff that we will not need. Save. Let's see. We have changes. You see, it marked as it was removed. What we can do is we can select this and reset. Yes. And look back. Oh, wow, it shows again. No, remove, save, update, see this change again, and like remove useless and for test commit. Yes, yes. Awesome. We have this view and this view. You see the difference even over here? At the beginning we have this, so always we can uh, check out it and get back to where we were, but we can continue. So now it sometimes we will do commits just to fix our positions, our current snapshots. It's easy. It's very useful to work. Modern Visual Studio also have Git included, so I think that I don't have this plugin. Doesn't don't care. Okay, let's add some more files. Okay, let's add arkanoid.h. Arkanoid.h. Arkanoid. I'm sorry. Arkanoid.h. Or let's name it somehow, not just an arkanoid, maybe like awesome arkanoid. Yes. No. Okay. Awesome arkanoid. Yeah. Let it be awesome arkanoid game. Okay. It will be global declarations. Now we will add C file that will be rendering engine rendering engine, and we will add uh, draw no image library image library not good name. Let's rename it graphics library. Okay, and another is uh, algorithm library. Okay, let's now split this stuff. My own technique is looks like this. It's easy to remove stuff, so I'm just copy everything. No search for online. Copy and paste here and here. Doesn't even know why it adds pragma once. What does it mean? I'll give you a second to think about it, then I'll show you how it works. Pragma once. Why do we need this? Think about it. Okay, before, so it's an awesome Arkanoid. It will be included everywhere. It's a basic and global uh, header file like Windows H, which is included everywhere. It's pretty huge. Our will be, I think, much fewer than Windows H. It's horribly huge. But this will be a global one. And the goal of this file is to, let's add this goal, all declarations, and no definitions. Yeah. So it will be definitions. Okay. It's also declaration. it's in line, so it have to be kept like here. We'll maybe move it from here. I don't know why do we need this. Okay, it's also declarations. It's also declarations. Oh, here is a definition. We don't need this. It's a definition. We don't need this. And this is declaration. This is definition. This is declaration. And this is definition. This is function definition. This is function definition. Function definition. Function definition. No need. No need. Now again declarations. Declaration, 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 definition. Okay. Definition, definition, definition. Definition, definition, definition. So it's inline stuff. I think it's internal stuff. It will be in the graphics library. So I think we can remove it. We'll always be able to we can remove this. We will never forget it because we have it stored here in a Git. So it's again, this Git is not a GitHub. It's a local repository. So everything is kept over here. Properties. Control panel and file explorer properties and view display show hidden, hide empty drive extensions, hide folder, no, hide protect, no, yes, restore, show encrypted, show use, okay, apply, okay, let's look. Yeah, we have two hidden folders. This Git folder contains everything. It has like not huge size. So this folder keeps all changes that we have made. So we can remove everything except this folder. And due to this folder and this Git application, we will be able to restore everything. So Git is a major stuff that keeps all history. This is producible option that can be produced by this folder. Okay, now let's continue to remove declaration. Declaration, 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 declaration. No, no, no. Okay, remove, remove, remove. Oh, sorry, it was definitions. Now it's declaration is definition. Definition, 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 declaration. Bresenham. It's algorithmic option. We can start from here. Again, remove, remove. It's declaration. We don't need this. I don't know what it is. Declaration, definition, 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 declaration. So after all these manipulations, after splitting, I want to get stuff that will be compiled again and get the same result on output. So again, it's definitions and main also not required in header file. So we got everything ready. Next, source, copy again, and now rendering engine. Put it here. Now we don't need this. We need to include or some arcanoid, awesome arcanoid.h. So now we can go no declarations, only definitions for rendering engine without renaming so far. Just keep stuff in the one place. So this is declarations, we don't need this. This is declarations, we don't need this. Declaration, we don't need. Now it's a little bit tricky here. I hope everybody can understand this, but I want to uh, remind you that this is declaration and definition in one place. It's declaration and definition. So let's remove it so far and look how it works. But it won't work good. But let's remove this stuff. So dx, it's for DirectX. It's stuff that for rendering. It's for rendering. This can be removed. Now again, I'm doing no declaration, only definitions for rendering engine. Okay, this is for rendering engine. This is for rendering engine. This, no, it's for rendering. Create, destroy, start. Okay, now it's no, it's for declare. It's for rendering. It's for rendering. Now it's not for rendering. It's for fixed image. Remove, 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 remove. Oh, where I am. You see, and when the file is too huge, it's hard to navigate. So I think that it's from beginning till the end. Nothing here. Yeah, it's rendering engine. Now graphics library. Copy, graphics library. Sorry. Oh, copy, paste. Now I need copy and paste. Now go copy only definition for graphics library. So this is declarations, declaration, declaration, declaration. It's for graphics, it's for rendering, not this. No need for this, no need for this, no need for this. And now fix create. It looks like a graphics library. Okay, it's like graphics library, graphics library, graphics library. Now it's looks like algorithmic. Quick with border, BT. Yeah, it's a Bresenham, it's algorithmic. Now till the end, no more. I think it's Bresenham, our stuff, Arcanoid. Yeah, no need. Now we got a second file ready, third file actually, algorithmic library. Okay, again, copy, paste, copy. I'm not insisting you to make a comment like go over here every time. It's just for you as a comment, as a extra reminding for what we have. Much better to create another way of comments, just for Actually, when you open any GPL code, like I don't know, it's like let's look at like GCC sources sources or maybe yeah, GCC sources GitHub. I want to online mirror. Just want to show you a very funny thing of like okay, leave GCC. Mhm. Do. No, it's not good. So the one thing I want to mention is at the beginning of each file, you can find in most cases stuff like this for copyright. It's good stuff for copyright, of course, but you see, we have here a small declaration of what actually presented here. For me personally, dfp bit.c doesn't tell me anything. Like it's something with bits, but what is dfp? I don't know. And decimal floating point over here, you see, it doesn't have any declaration of acronym DFP. It's not good. I think it's better to write something like DFP equal means declaration decimal floating point. But in most cases, at least my own experience showed that if I'm using some open source stuff, I'm see this header with with a huge explanation of copyrights like rules and all this stuff, but nothing about what exactly in this file. And the file may be like a couple thousands of lines, and with all these acronyms like DFP, like mm, deck, and all that. What does it mean? How it works? No explanation. Just whoa. So I think it's not good. Here is good enough. At least have some small declaration, but not always. Just one moment. Sorry. Pause. Next, what I want to say is so we are working on algorithmic. So for rendering engine for algorithm library. So actually, right now, what we are doing is we are taking this whole stuff, which looks complicated, and try to deal with this complexity by first using a tool of where it is. So we are trying to apply our tools decomposition. So we are decomposing the complicated stuff on huge parts. Then we will look at metaphor, and we'll look at composition, categorization, and goal thinking. Actually, we are writing goals. So we are using these methods right away with this exact example. So algorithm library, it's for algorithm library. We can remove all this stuff till algorithm library. On this, on this. Uh-huh. No. Okay. It's declarations, it's definitions. Definition, we don't need this. 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 And don't need this. So if we look at the source, we can actually extract one more file, which is for gameplay. Let's add a gameplay. New item. It's gameplay. Gameplay. And goal is for gameplay. So I think it's more fun to create an Arkanoid than creating some boring sphere and sorry, circle and all this stuff. So, and in this, copy, oh, sorry, gameplay. Uh, so far, I can keep this, I can keep this. I don't need circle, square shape, no need for this, no need for this. Okay, and I can rename it as Arkanoid run. Run. Okay, no need for this. Arkanoid run. And source will have only so source will have only a main function, and we will name it as a main.cpp. I think that actually naming like main.cpp, and if you have like 100 projects, all of them have main CPP. It's hard to navigate, but I think for today it's okay to have. So I need to include here. It's a goal entry point, and it's a gameplay. It's a function. We have to add it somewhere here, at the end maybe, as a declaration. And I can now run it, replace everything by this. So far, we have split it, we have do a decomposition, and now we need to compile it and get the same result as previously. And let's commit it just decomposition split all in major parts. Actually, let's, yes, commit. Doesn't even know who will it be compiled or not. Compilation will be successful or not. Think a little bit about it. The correct answer is no. It won't be built successfully. Compilation will be successful, link failed. Compilation successful, link failed. You see, all we can look at the error, we can look at output. LNK means linker errors. So compilation was successful, linking was failed. Why? Because of the problem that some global variables presented multiple times, because we have not declarations over here, but definitions. So we need to split our stuff and rearrange them a little bit. Firstly, let's allow it to uh, compile. Let's look here for declarations and definition and make them declaration only. So this is declaration definition. Extern, make it declaration. Extern, all this stuff I need to place to rendering engine. Goal is correct. It's declarations. Oh, sorry, it's definitions, not declarations. And this is only declaration. It's not a definition because it's extern. It means that this symbol exists somewhere, but not here. Where it is, linker will find it over here in this exact file. But that's why we have these problems, because linker have found the same symbol already defined in some else objects. So let's look next. Here, it's mode, it's extern, and this is for gameplay. It looks like it's even never used. Okay, fine, let it be. It's for rendering. It's also for rendering. No, it's for algorithm. Much better. Point, shape, okay, and this stuff. It's for rendering. Sorry, it's for gameplay. Let's compile. Hope it compiled this time. Failed. Multiple definition, full bar color. Bar color. It's extern. Why gameplay? Why it's presented 2 times? Let's look. Yeah. The problem is here. I have assignment here for extern. It's impossible. I have to remove it. Failed. Okay. Yeah. The same stuff over here. Okay, no assignment for here. No, because it's declaration, it's not definition. Struct x66. Okay, 66. Yeah, here. So it's hop, 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 string, hop for algorithm. And result external struct. Okay, struct. Oh, sorry, I have put it extern here. My bad. In C++, we don't need a keyword struct to be repeated. Awesome, it works. Now let's run. It works. Awesome. Now let's rename it as a main CPP, and let's commit it as a build fix. don't forget to save everything, and we need the solution to be changed. Oh, sorry, with CX project to be changed, yeah, over here because of this renaming build fix. Awesome. Now we are moving on. Now let's create some rearrangement. Now we have in object-oriented programming development, it's better to start from declarations and look at everything as a declarable way and then start to do some definitions. So let's look at the code we have here and try to rearrange it a little bit to collect parts the same like algorithm, gameplay, graphics engine, and rendering engine, and maybe start from graphics library to be ready to move on. So let's group all this stuff. Firstly, what we have, oh yeah, I have forgot to tell you about Pragma once. Yes. Okay, if I remove Pragma once right now, what will happen? The answer is nothing. Right now, it will build successfully without this Pragma. Yes, it works. But what if I got do something like this? We got undefined, undefined, redefinitions, previously definition, previous blah, 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 blah. Because we got twicely declared the same stuff. The the examples when we got two includes one by one, it's easy to find. And of course, I think in most cases, we will not get some problems like this. But what if you have some huge and complicated include structure when you have one files, another files, one include one, another one by another, blah 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 blah, and so it's some kind of hierarchical and very hard to determine whether this stuff is included or not. Was it included or not? So to keep uh, this stuff included only once, we can ask compiler to track on this and ask that this file have to be included only once. That's why we call Pragma once. With this, we have built it successfully. You see, we got includes, we got successful build due to this Pragma. The another option with Pragma is something for compiler specific. What we can do is to if and def something like awesome arcanoid h. So it's something like name of the file. Define fine and if oh, and if the same stuff. So if and def define if not defined do. If it was defined, this stuff will not be repeated. So let's build. It works the same way, you see. So Pragma once is a little bit more accurate. Now GCC also supports it. So I think in most compilers should now support this Pragma. But still, if you have some old compiler, you can do you can do a technique like I have give it to you previously. So if def and if and so on. Okay, let's now rearrange a little bit this stuff, and then next time we will continue to split all this stuff in object-oriented way. So now it will be includes. Now next it will be definitions. So it's macros and defines type defs. So it's macro and defines. It will mean this type defs. Time def, time def, think it's much better to look like this. So now I'm trying to rearrange the file structure to make it more looks better, just to make it easier to work with. So this is for graphics library. Globals. Globals. Functions. Now I'm trying to make some things looks better. Mm-hmm. Actually, so far we don't need these point shape square stuff at all. We'll start to work on Arkanoids, so I think it's better to be removed. Okay. Okay. Now let's split it for, so it includes macro, it's for graphics library. I don't know for what we need max and min. Let's try to, so firstly, let's build. Fine. Now let's remove this. Maybe we don't need it at all. Yes, we don't need them. It looks very generic, so I think it's, so let's do some splits. Again, we're doing actually the same decomposition, but now for one file, just to make it easier to understand. So it's, oh sorry, it's levels and its functions. Okay. Now, again, step by step. So it's a graphics library. This is for algorithm library. It's for rendering engine. And this is for algorithm. We have see that we have a multiple declaration of the same stuff. Okay, it's a rendering engine. Okay, okay. Now for let's group it. Graphics library. It's from graphics library. Actually, well, let's remove type defs like this. It will be union. Union. We don't need this. Just because in C++ we don't need type defs, so let's do. Right now we're doing stuff that named refactoring. Refactoring is changing the code without changing the result of this code. So the code become better in some way, but the stuff that it does doesn't change at all. So we don't change our result. I'm removing typedefs because this code was taken from C++, from C, and C++ we don't need this. Let's rename x86 as, actually I don't know what it is, so let's keep to x86. Properties. Okay, and yeah, I have forgotten. Semicolon. Okay, it's for graphics library. It's for algorithm library. It's for rendering engine. Game for, oh, sorry, for rendering engine. For gameplay. It's for rendering engine. Rhythm. I'm sorry. Rhythm library. It's for gameplay. Now again the graphics library. Let's remove useless functions which are marked on destroy we don't need. Image to image, no, let's keep them. So it's for rendering engine. It's for algorithm library. And it's for gameplay. Now we have again use firstly let's check. Okay, it works. Now let's check. It works. Now what we have done, we have done the refactoring, we have done decomposition, we have used decomposition method to decompose the file, and to one file to multiple files and one file to sections with a by rearranging and with the comments. Of the same actual method, but two different implementations. And after that, next time we'll continue this work and we start to apply object-oriented approaches to make this code better. First, as a hint, as an example, I want to show you is to use encapsulation. Encapsulation we can use like this is a global header, which is included even in a algorithm library, in graphics library, in rendering engine, but direct text is used only in graphic is rendering engine, and algorithm just absolutely don't care whether it uses direct text or not. So this we need only in rendering engine, and we don't need even this stuff in rendering engine. I mean, in a global scope, we can remove this stuff, build, and everything looks fine. But now we have hide the complexity or actual implementation that it uses actually direct text from rendering engine. Now we have only a top level interface with a render setup and start, nothing more. So this is the interface, and this is implementation that hides actual details. This is an object-oriented approach. We have an object like a rendering engine, it has its own state, and it has methods like functions as implementation. Next time we'll continue to apply this approach, do some renaming, and make this stuff. Let's commit like refactoring start or like stage 1. Okay, commit. Okay, I think it's all for today. Thank you. See you in the next video.